Yeah, my name is Nikita, so today I'm going to be speaking regarding inference and what we have in our cloud. I'm a head of product that is called Nebius AI Studio, and while we were developing it, we really found out a lot of insights that I want to share. So it's not going to be like pitch deck where we're trying to sell our product, but more like how to build the same product, or if you want to build the same kind of infrastructure internally, what it will take from you. So I believe everyone is aware here that there is a set of different applications arise during recent years. So I believe a lot of people now using copilots, chatbots, design and video software, and all of them are powered by AI in any way. And basically, we observed this 2 years ago, even more. And we believe that there is basically two trends going toward the inference. The first one, inference share is growing. So as for now, we still believe that training is using a bit more compute than inference. But we see that the adoption of the enterprises of the inference is growing, and there is a lot of interesting reports regarding that. And also more and more application coming into our lives. So that's the reason why all analytical agencies are forecast that inference will outgrow training. Otherwise, it will be a problem with the whole AI infrastructure here. The second thing is something that Alex already shared on the previous slides, test time compute hypothesis. All of the reasoning models and all of that stuff may be the best way for now how to make the model more clever. And when we're talking about inference, we believe it's not a lot of compute, but that's basically wrong. Of course, it's much less than the training, but still, just to produce one token with Llama 4.5b, you need around 1,000 billion floating point operations. And that's quite a lot, and it's just one token. So when you produce I don't know, a book, that means you need to multiply this a lot. And how much is 1 teraflop? So basically you can decode a video of 10 seconds in 4K quality, or just produce one token. And yeah, so as I said previously, we started as a cloud that were looking quite deeply into the training. And last year we started research. During the summer we did a lot of R&D regarding all of things that can be done in inference, and released our product in Q4, and we're going to be talking about it. So what customers need, that's obvious. First of all, they don't want to care about maintenance of the infrastructure, and they want it to be scalable. So they don't want to think about I know, wrapping a couple more GPUs or shrinking a couple more GPUs. They just want okay, I have demand. This hour is this amount of tokens. I want it to be working. And as the business grows, they want to go with it. So scale is one of the things that customers want. The next thing is stability, speed, and quality. That's quite an obvious thing. So they want everything to be stable, quite fast, and the quality should be as in original models. And of course the price, that's what customers want and where they can go. So if you're thinking about the inference, there are basically 3 paths. The first path is rent a couple of GPUs in IaaS and build the inference service on yourself. The second option is go to some providers that provide you a per hour or kind of serverless approach, so you can easy spawn new GPUs, delete these containers and so on, or you can go per token. And while we were observing, we found out that there are basically 3 sets of problems that might be solved by different ways. So the first one is hardware. And what's the problem with hardware? So basically, there is a scarcity, even if it's not a scarcity in general for all the chips. There might be a scarcity for some specific chips. And different models require different hardware. So for example, models less than 3 billions can be launched on top of iPhone. The small models, 7B models, can be launched on top of old cards. Llama 70B can be launched on top of H100. And if we're talking about Deepseek, the most convenient way to run it now, you need the full host of H200s here. So yeah, here you can see you need all of the cards, and that's something that can offered by IaaS providers. But moreover, chips are going to be the better. Basically, we had a talk from NVIDIA today, and new chips gonna deliver better performance. So, for example, here you can see this is the public benchmark from ML Commons, where they benchmark what amount of tokens you can squeeze out of the specific hardware. And here you can see that Blackwell's gonna rock. And this was I believe, made even with some software optimizations. And we know that Int 4 is coming, and it's going to bring even more like economy out of these chips. And we believe like they're going to be like 10 times faster around that. The next problem is fleet management. So that's something that you can't solve if you go to IaaS. And what do tech problems like arise here? So as I said, customers want quality, they want speed, they want price, and also they want the scale. And what is the problem with the fleet management? So here you can see the graph of specific customer that we have, and that's how the demand is looking. So it's quite obvious that depending on the day, like depending on the hour, the demand might be higher or less. So here is like RPS, like amount of, I believe, requests per minute. Yes. So there is spikes, and to address these spikes, you need really to orchestrate your infrastructure in quite an efficient way. So first of all, if the model is not used, you need like to shut it down. But when it's starting to be used, you need to bring it back up. But basically, models are quite big. Like if we're talking about Deepseek, it's 600 gigabytes, and just to read it out of the disk takes like minutes. And in this case, it's quite a problem that like customer came and you're spawning up the model and you won't get response like fast. Scaling one-to-many can be solved like much easier and in more convenient way if you have InfiniBand inside your cluster, so you can just replicate some deployment that is on the next node. That's something that involves a piece of engineering, but like solvable. And also there is a set of things that like if you have a successful application, probably you need to think also about network latency. So you want to have your service in every region. So that was about the fleet management. And the third problem that can be addressed mostly by the providers who provide token per service, token as a service. So is model to GPU optimization difficult? Basically, that's a set of techniques that like we currently utilize within the Nebius, and you can like use them on your own, but I won't be talking about all of them. So first of all, inference engines. I believe you've heard many of these names like VLLM, TensorRT, SGLang, TGI. That's all quite like good frameworks, and they provide different performance depending on the data you're checking. So basically, they're really evolving very fast. So from day to day, from like month to month, one framework can be better on some specific model, another framework can be better on another model, and in a month it can be vice versa. And basically, the second problem with these frameworks is that they have a very high pace. So basically, over the last months, there were more than 400 public pull requests to the upstream of the VLLM, and more than 200. And that means that there is a lot of code from different contributors. And this also means that there is no single stable version that is available there in the internet. You can't just download and launch. For sure, something won't be working. And if you want to like build some reliable piece of software here, you need to do a lot of testing. So basically, we test all of the like versions, all of our endpoints, every point of the like time, day, and so on. And we have quite a set of tests here to be sure that with new release that agentic functionality will still be working and the speed won't degrade too much and like stuff like that. The next thing is like quantization. I believe that's also like all the ML engineers have heard of. Like there are a lot of different algorithms. There is also a lot of different models that are already available pre-quantized on the Hugging Face. So here you can check like it's Llama 3.370B that I checked on the Hugging Face, and there is more than 400 distribution, I believe, here. Of course, part of them are fine-tuned, but like also, I believe, around half of them are just quantized version. And what's wrong with quantized versions? Like they might perform better, but they might lose the quality. So basically, within your software, within the inference service, you need to build the pipeline and tooling that will check that while you're changing like the data types, while you're quantizing the model, the quality relies the same. And that's something that also need to be implemented. The next thing is like speculative decoding. That's also quite a popular technique. So it's quite obvious. It's quite, yeah, that LLMs, they produce in token by token, and prediction of some of the tokens are much easier than prediction of like another token. So here you can see like we're trying to predict the University of Edinburgh, and it's much easier to predict the word of, and any model can do this, even 1B model. But the Edinburgh is much more difficult word to predict, and in this case, you need an original model. And that's a technique. If you want to implement it, you need to go and check like what are the best draft models for the bigger versions. Also, this technique doesn't like change quality at all because the draft model predicts some like amount, like let's say 10 tokens in advance, and then the bigger model checks that all of these tokens are correct. So no quality degradation in this case. But also, it is like almost all frameworks support this, but there is a capability matrix. It doesn't work with agentic tools and stuff like that. So that's a thing that can give you boost. And here I show what is the boost. So here is like the moment when we enabled the spec decoding on our endpoint, some of our endpoint, and you can see that the speed grew like most 2 times or even more than 2 times. Yeah, and that's what you can get from the spec decoding. It's in there, but like you need to cook it. The next thing is prefix caching, and that's also a technique that is available within every server or almost every service that like I was talking previously, like SGLang and VLM for sure. But what's the problem? If you have a scale, as Alexander previously said, like you need to implement a sticky session or some kind of like distributed prefix caching. What's the point here? So there are a lot of use cases where people send the same prompts for many requests. For example, you are working in a code like IDE, and you're sending the context of the code window, like where you like currently writing the code, and you're sending the same context, and you just add 1, 2, I don't know, 3 tokens every time, but still 99% of the prompt is the same. And in this case, why would you need to, like, what would you pre-calculate all of that tokens every time? You can just like cache it and then take it from cache. And it works quite fine if you have one deployment, but if you have many of them, you need to like do this prefix cache aware. And here you can see it's like the real load from one of our endpoints. And basically, the moment we enabled our cache aware routing, the cache hit went from 10% to 50. And yeah, and that's something that can be helpful and also help a lot. So yeah, that's the small part regarding the stack and what like needed to be done in order to like build an inference service. But why are we building that? Like for sure we have a lot of different services. Also like there are a lot of trade-offs. So basically depending on like how do you quantize the model, what is the tensor parallelism and some other parameters, you can get either like more fast endpoints or like more cost efficient endpoints. And all of the providers pre-compile their like parameters, how they serve. And here you can see the matrix. So basically all of the providers have different, let's say, parameters and qualities. In order to address this, we do 2 endpoints. The one is base, another is fast, a bit more expensive, but also much more faster. And yeah, so we released our product. Basically, it addresses all the issues and solves all the problems that I was talking about previously. But like, why using open source models? Why not just go to OpenAI or I don't know, Claude, Anthropic? So I believe the news regarding releases of new model like are shaking the world quite drastically. And basically what we can say for sure, maybe if we're talking about state-of-the-art performance, they're like proprietary models might be the best, but this like is shaking. I would say like a year ago or so, there was no doubt that like ChatGPT-4 is the best. For now, like Deepseek released, it's kind of better on some frameworks. Llama 4.5 was released, it also was kind of better on some of the frameworks. And basically what we can see, like open source models rock, and why not use it? First of all, like it's similar quality baseline. Sometimes you can achieve better speed with open source model because there is more option how you can deploy it. It's not some specific provider who did this service once, and also sometimes you can get better pricing and fewer like privacy concerns. So like you can go and check with the provider how they treat your prompts, how they treat your outputs, or maybe you can build like self-hosted infrastructure. And when we're talking about like state-of-the-art models, here like the graph, so you can see like, yeah, O1 is like, probably this slide is a bit outdated, but like it's among the best. But if we're talking about the price, it's like much more expensive. If we going about the, like let's say smaller models, I wouldn't say small models. Okay, I wanted to go. Yeah, here it's not that obvious already that like these models are the best. For example, like here you can see Gemini, you can see Claude, and on the like medium models, I would say like there are quite competitive endpoints from open source providers. And moreover, if you choose specific model, you can also see that there are many options where you can take this API, and so you can get like different parameters depending on what you need. And what I would also talk a bit today is like the models. So basically, how to understand which model would be the best for you. Like that is a set of criteria. I'm gonna go through some of them, not all of them, but basically, yeah, for sure. First of all, we go with the modalities. Like you need to understand your like application, what you're doing. Like, is it some code assistant? Are you gonna do some speech to text, or are you gonna do some text to image? And yeah, and basically, like there is a set of models in all of that categories. And then you need to think about the quality. And by thinking about the quality, that is a bit more difficult question because there are a set of different frameworks, and it's basically impossible to rate some specific mark for model and just treat it as a like I don't know ideal mark. So you can't make a scale for all the models that will fit all. A lot of different like let's say communities try to do so. So there is a Hugging Face OpenLM dashboard, there is a Llama Arena, there is also an artificial analysis. Let's say they call it intelligence index. But basically what's more important when you understand what like piece of software you're trying to build, you need to go deeper into the like what kind of knowledge you expect your model to have. And for example, if you're going for code, you can go to like MBPP. If you go for math, you can like check the math, multilingual, tool use, and so on. And there might be some unexpected results within specific frameworks. For example, if we're talking about tool use, currently the like state-of-the-art model is not like proprietary model. It's a fine-tune of Llama, and that's the model that you can just like take and like spawn it on your own, maybe use some provider, and it will perform better basically than the private models. And that works for many of the frameworks. Of course, on like most of the frameworks, the private model is going to be the best, but here is an example where it's not so. But if you want to like really build like a software, after checking the framework and defining a set of models you want to try, if you want to go deeper and understand better what the model suits you the most, you need to go to the like more personal approach, I would say. So you need to craft a golden data set and understand like on what inputs you like expect these outputs. When you craft this data set, you need to choose an evaluation criteria. So like, do you want to check, I don't know, toxicity, relevance, or some other criteria? And then you just like do the loop, like you evaluate and then you reiterate. So you change the prompt, you fine-tune model, you choose stronger model, and like rate all the models that you have, all the like parameters of the system. You can tune them, and then you like evaluate, evaluate, and evaluate. There are like a set of publicly available frameworks that might help you to do so. Like here you can see the names of them. So most of them are using LM as a judge, so they're using bigger models in order to check if this bigger model can interpret the results of the smaller models for specific parameters. There is also like a specific framework for these evaluation models where there is like fine-tunes of the open source models that can perform the task exactly of evaluation the best way. And yeah, so how do we iterate? So first of all, it's prompting. You can try different prompts. You can add more information about the relevancy. Then you can also fine-tune the model if you already have the data set and you understand how it should perform within this data set. You can just like fine-tune the model on it and expect it to perform better. Also, you can use reg for grounding. So it's like if you have a database with relevant data, you can get this data every time. And yeah, like changing model, decomposing the task, and stuff like this. The next thing that I'm going to be talking is pricing. Pricing also is a bit not this clear with all of that model. So basically, there are input tokens and there are output tokens, and what we observe internally, the price of processing like X amount of input tokens is less than the price of producing of the same amount of tokens of the output tokens. And you might be misjudging sometimes the pricing on all of the inference services that, for example, here you can see there is a provider who has the same price, 1.5, 1.5 for input and output, and like provider 2 that has $1 and $3. And it's not obvious which one of them gonna be like cheaper in your case, and it's better to check. Like what we observe currently internally, the most popular ratio of input and output tokens is around 50. So basically, when people use LLMs, they send big prompts and they're expecting quite small outputs. And in this specific particular case, the provider 2, which pricing might look on the first glance a bit more expensive, will be cheaper. So that's also something that you might want to check. Agentic capabilities, yeah, like that's a pity. Like we really spend a lot of time on tuning and assure that this works as expected in our software. And I believe if you would come, I know in October, you would experience some of the bugs. Currently, we're sure that it works as it is. Like we support OpenAI stack, and like not all of the providers support it, and moreover, not all of the frameworks support it. And if you want to build inference, for example, on your own, and you like using SGLang, please test it twice that it performs as expected, because like there are a lot of things that dig down here. So yeah, we talked a bit how to choose a provider today. I'm just gonna like save this slide. Maybe you can share it afterwards. And yeah, so a couple of break words regarding our product. Like that's what we have. All green here is what you can use already. All the gray here is something that gonna be soon. And the I'm not sure how to call violet. This is what like we're gonna deliver in the next week. So what we see that people are expecting, it's like inference, fine tuning, and also the playground where you can tune all of the like prompts and the results of your parameters configurations. And yeah, here's the promo code, so please check it. You can get $100 on our like fancy product, and that's all. If you have any questions, I'm eager to answer.
Any questions? I actually have one.
Yeah.
So you know how actually, one of the story behind the studio, it was fun that when we first time met with Nikita, we said, let's play with the models. Let's take what it is and let's try to run them. And actually, this is how Nikita started to build the studio. It was fun. Nikita, do you think that still people, like imagine that you're just starting something, experiments. So do you think that going and running your own model in a virtual machine in any cloud or on your desktop is actually makes sense, or it's much easier to go directly to the inference service?
I would say if like you're just starting to create your own business and your first like idea of what you want to do is like to run a virtual machine and check all of the configuration that is there, I would say that that's bad case. You should probably observe better the use case in the world that you're trying to solve. And in order to make your life easier, I would say for the first iteration, like private APIs might be the best option here, because on average they deliver the same, like close to state-of-the-art performance. And then when you will see that like it's not enough in your specific case of this like private API providers of this specific API provider, you can go to another one. Another thing, when you're starting your business to grow, that's the thing where you need also to go deeper. But maybe at the start, I wouldn't be starting the VLM on my own on virtual machine for sure.
But what will be the criteria to understand that it's time to evaluate running my own inference in the cloud or in a data center or somewhere else? When it's how to understand that it's time to actually start to think about it?
I would say it's not like one answer fits all. But in my opinion, it would be that you have enough money to invest into this. Like basically, you need like a team of engineers. I believe like at least up to 10 to build like a good inference, and you really have this cost quite big one. So you might optimize it better than solutions that are there present on the market, but it costs a lot.
And regarding fine tuning, you mentioned that it could boost the quality, and it sounds like as if there are services who provide fine tuning as a solution, just click a button and you get it. When it's actually time to think about fine tuning the model, does it make sense to do that from the beginning, or maybe I need to start with just standard model?
I would say it's also quite a broad question. So everything depends on the case. Like with fine tuning, what you can get is also like the same. So you can optimize your cost, basically distill a bigger model to a smaller model on your specific use case. That something can be done with fine tuning quite easily. But while you're paying, I don't know, like $100 per month in your specific application, maybe you shouldn't be caring about that, because the time that you will invest into that will just like cost more.
Okay. And maybe last question. So usually when I'm thinking about fine-tuned model, it means that this is my own model, and I have to run it on dedicated capacity. So from price perspective, from cost perspective, is fine-tuning model is more expensive and using and running them than just taking an open source model?
That's a good question. Basically, it depends on how you run it. So, for example, within the studio, we have this option of running LoRa adapters. So, instead of like doing full fine-tuning, you can do a LoRa fine-tuning, which like goes faster, and also you get the adapter. And then in the end, you can like still host it on the same prices, like per token prices. Basically, like it will be the same within Nebius AI Studio product. And yeah, in this case, the cost of ownership is the same, I would say.
Okay, so just to recap, in the studio you use LoRa, which means even if I fine-tune the model, I still pay the same as I will use the standard model.
Yeah, that's correct.
That's cool. I'm asking actually, it's not like playing a role here. Actually, I'm asking because they released it yesterday.
Fine-tuning, yeah, we released it this one.
I didn't have a time just to check it, so I'm asking questions which I have in my mind. Any other questions? Just a couple of seconds. We have two questions.
Bonjour. So you presented the part where there is infrastructure, the training, the GPUs for training, and you've presented the inference part, fine-tuning eventually with the studio. I haven't really seen the tools to link. If I do my own training, if I want to evaluate performance, I want logs, I want the data set, I want to link dataset IDs with model IDs. How do I manage that on your platform? Do you have integrated solutions? Do you provide anything to facilitate the transfer from a training perspective to an inference perspective and the switch from training to production?
Amazing question. You just, warm my heart. Because I actually just, in Nebius, I'm leading exactly the part of the product. We haven't talked about them today because we were interested to talk about the insights which we learned during the building the system. But we have them. So we, to do this specifically what you asked, we designed serverless Spark, which means you can just bring your data, you can bring your PySpark file, and we will run it for you. Serverless, you will not see the cluster, you need to manage that, and you will pay only for the time of the CPU RAM that you have used. And for the experiment tracking and lineage tracking that you mentioned, we have managed MLflow, where you can use MLflow as a service, and we manage backups, databases management, tracking server management, and other components of the MLflow. And we have SLA and etc. things. So there are tools, yes, we exist. It's in the middle exactly between the cloud as a compute and AI Studio as a part. So they also exist. We just didn't talk about it because it's a good question why we didn't talk about what the challenges we have when we implemented MLflow, because there are challenges. But yes, we have them thank you for the question. Like, you really touched my heart. We have another one question.
Yeah, so hello, thank you for your presentation, Nikita. I have a question about when you have mentioned the example of token generation, like in the University of Edinburgh, does the model check the accuracy of a single token or a set of tokens? So how does it actually work?
You mean the bigger one?
Speculative decoding.
Yeah, I understood that that's a question regarding the speculative. I have too much slides. Sorry for that. Yeah, so in this case, basically you go for the original endpoint of the bigger model, and the smaller model pre-generates a sequence of 10 tokens, let's say, and then the bigger model checks all 10 of them. And if only first 3 fits, for example, it takes these 3, and after that generates on its own. And that's something that goes in parallel with execution of the bigger model. So because it's much cheaper to like check if the answer could be found easier with the smaller one. Okay. So you can also find me in the networking area. I'll try to go till the end.
Go to the end. Any other questions? Oh, we have one more question.
Okay.
Oh, you have your own QR code.
No, I believe that's yours. Not yours, but like ours in general, not our product exactly.
Hello. I want to ask if there is a way to, when there is an output in the AI Studio, is there a way to, an API perhaps to channel that into another front end or another service?
Can you repeat one more time?
Like
So,
when you see the generated output from your AI models in the AI Studio, can you take that and put it into some other front end, for example? If I want to use that in my product, can I do
yeah,
that?
sure.
Okay.
Like you can, basically, there is some legal stuff might be involved depending on the model, but from the technical perspective, you can take and use it wherever you want. From the legal perspective, it depends. For example, I know if you take outputs of Llama and you fine-tune some other model, you should like release. If you're going to be releasing your model, you need to release it under the same like license. We have this written, like we have a legal team who's writing this in our terms of service. So it should
I
be
think
quite
Nikita's
obvious.
question was more about SDK API connection.
SDKs.
More about the SDK API. Yeah.
Like we are OpenAI compatible, so basically you can use OpenAI SDK, and you just like change the name of the models and the
Token.
base URL, so like the URL of the API.
URL. Yeah, so you can use any library, LangChain, Langsmith, whatever you want. It's fully compatible.
Basically, we have like set of integration with LangChain, so you can use Nebius AI Studio within LangChain out of the box. So like it's just import and that's all. And also recently we got an integration with Hugging Face. So from the Hugging Face interface, you can also use our product.
Yeah. Any other questions? Looks quite good. Thank you so much, Nikita, for the amazing talk about what actually it means to build an inference.